All right, so let's look at what a microcontroller really is. Many people say it's a very small computer. Not totally true. Some microcontrollers uh, becomes bigger, but it becomes then more computers than just microcontrollers. And I'm just using the lesson to step us through what a microcontroller is all about. So it's an IC, and in the previous module, uh, you saw them. Some of them are as small as the nail on your thumb, and some even smaller. And it's surrounded with a lot of electronic components. Most of them are for stability, and power management and things like that. Now, what a microcontroller does is it's usually used to control other devices or to read things like temperature values from sensors and so forth. It can, for instance, monitor the speed of a motor or switch on LEDs, all outside lights, and so forth. So the coding of it generally, in the old days, it was not that easy. Today with AI, you simply just tell it, you'll use a master script that we'll explain soon, and you just say, if it's day, turn on the light, if it's night, turn off the light, and it will create all the code for you. But it's quite, uh, if you look at the explanation here, it says a microcontroller is a compact integrated circuit, an IC, designed to govern a specific operation in an embedded system. And that's true. So you can have a whole system that monitors things, that's doing things like facial recognition, and the microcontroller is that thing that makes all this happen. It will get the images, it will compare it to maybe other images in a database to see, is this a staff member? If so, allow him in automatically, maybe at a security gate, and so forth. You can set that up at your home as well. If you walk around in your house, you can have the alarm on. It will recognize you, but as soon as it's not recognizing a face, the alarm will go off. So, as it says, think of it as the brain of a device capable of executing a predefined set of instructions. Now, that is the code. If it's day, do that. If it's night, do something else. If the temperature is higher than this, send a WhatsApp, whatever the case may be. All right, and the key features is it does have memory, just like a computer, but not nearly the amount of memory because it doesn't need that. It doesn't come by default with things like graphical user interfaces and so forth. So it does not need a lot of memory. As your application grows, so you'll get bigger microcontrollers that is sufficient in memory, maybe for facial or object recognition and so forth. Then it's got a lot of pins. Now, I don't know if you can see this. I don't think you can. I just want to move to a different view, but oh no, you won't be able to see it. But if you look in the previous video, this microcontroller, for instance, got about 50, 60 pins. All right, and most of these pins are called input pins or output pins. Some of them is for specific things like connecting to external memory to increase the memory size, or a power type of pins, but most of them are pins to input, meaning something is coming into the microcontroller, maybe a temperature reading, or something go out of the microcontroller, like like getting a motor to speed up or slow down, or dim lights and so forth. So there's input pins, there's output pins, uh, and then the processor itself. So the memory, there's different kinds of memory. We will look at that soon, but there's a memory that will hold your program for as long as you don't override it, and that memory uh, stores your code, and it's called flash memory, and it's not going away when it loses power. It's in there permanently until you change your code, that is. So that is really what a microcontroller is, and you'll seldomly find that you'll just use a microcontroller. It will normally be in the form of a board that already have all the power sorted out for you, and many times there's already things connected to it, so you don't have to use expansion pins as explained in an upcoming video. It's just pins that's there, so you can add things like sensors and so forth to your microcontroller. You'll find microcontrollers all over the place. You'll find them in wearables, watches. You'll find them in home automation, hardware, and so forth. So the idea for us is to show you how to code them. You don't need to be an electronic fundi or even be interested in microcontrollers. There's many available on market. We ourselves has produced many that will be all you need for a task. You plug it into your computer, get something like Cursor to program it for you, and that's the end of that. Of course, most microcontrollers these days do have Wi-Fi and Bluetooth built in, so you can send data to a database and then use your skills that you're going to build to pull it into maybe a browser to display values and things like that. So that's it about microcontrollers. They're much easier. Just because it's something new doesn't mean it's difficult, especially now with AI doing all that coding for you. I'll see you in the next video.